I'm going to deliver on a promise I made last fall that we would talk just a little bit about the results coming out of this mission. Dawn was the first sort of heavy-duty use of ion propulsion on a spacecraft for solar system exploration, and it visited the large asteroid Vesta. It was able to go into orbit around Vesta for a couple years. Then it turned on its ion engines again and transited to the largest asteroid in the solar system, the dwarf planet Ceres, and it's been orbiting Ceres for a number of years. And one of the mysteries that came out of these observations was a variety of very bright spots on Ceres. The background reflectivity of the average surface is something approaching charcoal, fairly dark, and these bright spots reflect about 50% of the sunlight coming in, so they're more like dirty snow. And what was really exciting was the possibility that maybe this was water ice that had been burped out of the interior of Ceres and formed ice deposits. And I think we've got a very short video here of a couple of the researchers that have actually been spending a lot of time on this problem, and they'll try to explain it. Maybe. All right, Mitchell, I'm not sure why we don't have any sound.
Processes are modifying the surface even in the present
because
day.
I had it muted,
Approaching
that's why.
Ceres, we saw this
Let
very
me back
bright
up.
region on the...
When folks think about asteroids, they might think about dead chunks of rock that are floating around space. And what we see with Ceres is that processes are modifying the surface even in the present day.
Approaching Ceres, we saw this very bright region on the surface. And then as we got closer and closer, you saw that there were multiple bright regions in this one crater. There's the one in the center, which is called Cerealia Facula. And then there's the ones off to the side in the crater floor, which are called Venalia Faculae. Cerealia is located in a pit within the center of the crater. That pit is about 10 kilometers wide, and so it's about 1/9 the diameter of Octocrater itself. And then within that pit there is a little central dome.
What we're seeing is an indication that there are liquid brines, potentially in the subsurface even in the present day, rising to the surface and becoming these bright spots. And that tells us that there has to be a process providing energy to drive these fluids to the surface. We call them bright spots, but actually it's a relative term. The brightest bright spot on Ceres, Cerealia Facula, has an albedo of around 0.5, which is about the same brightness as dirty snow. Bright spots on Ceres aren't limited to a single place. We found that there are over 300 bright spots all over the surface of Ceres, and that indicates that this is a relatively widespread process.
The salts that we see in Octocrater are similar composition to salts that we find in Mono Lake in California. It's interesting that you can have these similar materials found in different places that were formed by different processes.
Ceres represents something of a bridge between the bodies of the inner solar system and the outer solar system. In the inner solar system, we see rocky bodies. In the outer solar system, we more broadly see icy bodies. And Ceres is sitting somewhere in between. We know now from the bright spots that it is changing. The bright spots that are already on the surface are darkening over timescales of hundreds of millions of years or even less. And we also see that the bright spots maybe are still forming. So Ceres is still an active body. And we still have a lot of questions about what are the processes that are modifying Ceres' surface over time and what that tells us about the internal nature of Ceres and how it actually formed.
Okay, so salt water is what it amounts to. Before we move on to Mars, the Dawn mission right now is in the process of lowering its orbit. It's got, they think, somewhere between 6 and 12 months of propellant left. on board, and so they're trying to slowly drop the orbit to be closer than what they were during the primary mission, and that will, of course, allow a lot higher resolution of the both the imaging devices and or the cameras on board and the other instruments on board. So we'll update this as the year goes on, but for the moment it's still alive and kicking.